Good evening, YouTube. It's me again, and tonight we have a short video on an introduction to trigonometry. This video is relevant to students in normal academic, normal technical, as well as express streams. But if you are looking for further trigo identities as well as application of trigo, these will be covered in other videos. All right, so let us start off with a simple introduction of trigo in this video. So here we go. Well, what is trigonometry? Well, first of all, students can't pronounce trigonometry. Some teachers can't pronounce trigonometry. We shall rely on the word trigo. It's a branch of maths that looks at the relationship involving lengths and angles of triangles. Okay, so for these introductory video, we will look at the relationship between the lengths and angles in a right angle triangle. Okay, in a right angle triangle. For those of you who are struggling with Pythagoras theorem, I strongly suggest that you check out the Pythagoras theorem videos first before you carry on with this video, because it's important that you know the relationship of the sides of a right angle triangle and how they relate to each other before we carry on with this video. Okay, now in the Pythagoras theorem, we saw that in a right angle triangle over here, in a right angle triangle over here, excuse me, let me change the color of my pen. In a right angle triangle, the longest side of the right angle triangle, or the opposite side or to the right angle, is called the hypotenuse. Okay, the hypotenuse is the longest side. Okay, now there are two other sides of the triangle that we need to name. But first of all, we need to we do need to identify, or we need to recognize that there are two other acute angles over here inside the triangle. Now, what are acute angles? Just a revision, acute angles are angles which are less than 90 degrees. Okay, so that there are two angles over here. We can name these angles alpha and theta. Okay, so 90 and alpha plus theta makes up 90 degrees, but individually alpha and theta are less than 90 degrees. Okay, so if we forget about theta over here and just concentrate on alpha, we notice that alpha, if you imagine theta, if we imagine theta to be an eye, a yanqing, or what you used to see, and you look across the triangle from the perspective of theta, you reach the opposite side of the triangle from theta. So this is what we label the side opposite theta. Very intuitively, it's the opposite side to theta. Now, so we have named two sides of the triangle, the hypotenuse as well as the opposite. What's left is this side at the bottom. This is called the adjacent. Okay, so it's important to know which angle you're looking from, because as we said just now, there's another angle alpha, which is over the top here of the triangle. Now, if we look at alpha, and from the perspective of alpha, if you draw a line to the opposite section of alpha, you notice that the alpha's opposite side, the side opposite to alpha, is at the bottom instead, and is different from the opposite side to theta. Okay, so it's important to see where you are looking from, which acute angle that you are taking reference from. Okay, and this would then be the adjacent side to alpha. Now, notice that the hypotenuse hasn't changed because the hypotenuse is defined as the longest side of a right angle triangle. So the hypotenuse will not change. The only two sides that will change is the opposite and adjacent sides. And how we can identify it, we need to make sure that we got the right reference angle. If we got the wrong angle, we will identify the wrong sides, and every other calculation that we have done henceforth will be wrong. Okay, so let us have a practice again. If the right angle, let me hang on. Let me just change my pen color. Okay, if the right angle is here, where's the hypotenuse? Yes, I think some of you are still struggling, or some of you are getting it right. The hypotenuse is over here, the longest side of the triangle, or the side opposite the right angle. Now, if we have an acute angle theta over here, where is the opposite side of theta? Alright, good. Alright, the opposite side of theta is over here. If you draw a line, it's across, and then the remaining side is the adjacent side of theta. Sorry. Okay, adjacent side of theta. Now, moving on, there are three basic ratios that we have to cover in basic introductory trigo: the sine ratio, the cosine ratio, and the tangent ratio. Okay, now we have three sides over here: the hypotenuse, the opposite and adjacent, as well as theta. Now, the ratios relate theta to the sides. Okay, it relates the angle to the sides. So we will make use of the sides in the ratio. So a useful mnemonic to remember the ratios is in a Singapore context is tua ka so, or big-legged auntie. Okay, tua ka so, that is what it means. Tua is big, ka is leg, so is auntie. Okay, so tua ka so. Please do not call your aunties that. You will get a big tight slap across your face. So please do not do that. Now, tua ka so is very easy to remember. The first three letters, okay, TCS, relate to the ratios. T for tangent, C for cosine, S for sine. Okay, so the first letters refer to the ratios. Now, the second letter and the third letter over here forms the ratio of the trigo ratio. Now, the second letter will be the numerator of the ratio, as well as, and the third letter will be the denominator of the ratio. So if we take T for tangent, okay, tangent theta, okay, which is tua, okay, it's O over A, okay. Cosine theta, okay, we'll have A over H. And lastly, for sine, please do not use the word sin, okay, it's O over H. Now, what do these mean? Okay, now O, it's opposite, A adjacent, okay, and A is adjacent. H is for hypotenuse, and O opposite again, and H is hypotenuse. Okay, so if you can see, these are the ratios that we have found out. Tangent theta equals to opposite over adjacent, cosine theta adjacent over hypotenuse, sine theta opposite over hypotenuse. These are the ratios, or that relate the sides of a right angle triangle to the acute angle that we are taking reference from. So if this is a triangle, right angle triangle, theta is over here, okay, 3, 4, and 5. If this is the basic, is one of the more popular trigo triplets. Okay, so from theta over here, we see that this is the opposite side. This is the hypotenuse, as well. This is the tangent. Sorry, the adjacent. Now, if we are looking at sine theta basically means what is the sine ratio of the triangle, taking reference from theta. Okay, so sine theta from what we saw just now is the opposite over hypotenuse, which is in this case the opposite is 4 and the hypotenuse is 5, and this is a 5. Okay, so this is the ratio of sine theta. For cosine theta, it is adjacent over hypotenuse. If you look at the adjacent, where the adjacent is 3, the hypotenuse is 5. And lastly, if you look at tangent theta, okay, it's opposite over adjacent, which is 4 over 3. Now, this is extremely simple. If you have a problems understanding this, just drag the slider back of the video and just go through again what the ratios are. The ratios are very simple. As I said just now, you remember it through the mnemonic Tua Ka So, okay, where the first letter of Tua Ka So refers to the tangent, cosine, and sine ratio, and the second and third letter represents the ratio. The second letter being the numerator, and the third letter being the denominator over here. Okay, so take a time, just rewind the video, just drag the slider back and just revise this. Okay, so we need to understand next is the difference between sine theta and theta. Now, sine theta is a ratio, so is cosine theta and tangent theta. When you talk about sine theta, cosine theta, and tangent theta, these are ratios. Okay, sorry, ratios. This involves identifying which sides to be the numerator, which sides to be the denominator. Okay, now when we are looking for theta, theta is an angle. Okay, it is an angle. We want to find the angle. So if we are asking, if given a triangle, okay, and there's theta over here and it's the same dimensions, 3, 4, 5. If I ask you what is sine theta, I want you to express sine theta as a ratio, which is opposite over hypotenuse, which is 4 over 5. Okay, now sine theta as a whole, it is one term on itself. You cannot separate sine and theta. Sine theta, there's no it doesn't make sense that what is sine equals to 4 or 5. Now this is wrong because there is no reference angle. The whole, you would need to put your reference angle as sine theta. Okay, now if you want to find what is theta, the theta is an angle. Okay, so for example, sine theta is 4 over 5. Okay, and you want to find sine theta, you want to find theta, you would need to take the sine inverse, okay, of the ratio to look for the angle over here. Now, this is available on your calculators. I think it's press shift sine, you get sine inverse. Some students call it sine minus 1. Well, the exact term is sine inverse. Okay, so if I can quickly pull out the scientific calculator, and you can go inverse, you can see the word sine, okay, 4/5, okay, and make sure your calculator is in degree mode. Okay, you notice that your angle is 53.1 degrees. Okay, 53.1 degrees. Okay, the same thing can be done for cosine and tangent. For example, cosine theta is adjacent over hypotenuse. Okay, you want to find theta, you just take the inverse of the ratio of the sides. You will get the same answer. All right, ask your teachers, why do you get the same answer for theta if you do this, if you use this dimensions. I think your teachers will have a good time answering you. Okay, basically the short answer is because we are measuring the same angle, the same reference angle. So very quickly, what we have gone through, the basic trigo identities, the basic trigo ratios, sine, cosine, tangent. How do we get the ratios? Okay, using the mnemonic Tua, Ka, and So. And of course, finally, the difference between sine theta and theta. Now, I'm doing this set of videos to help my students as well as help you. If you find this set of videos useful, please let me know in the comments. Let me know how I can help my students better and how to make these videos better. Till next time, I wish you a wonderful school holiday, YouTube, and I'll see you all really very soon. Thank you.